All right, so you're getting ready for this big business data analytics exam, huh? We're going to help you out today.
Yeah.
Not just to pass it, though.
Oh, no.
Really understand this stuff.
That's the important part.
Yeah, we're going deep into this prep course syllabus you've got.
It's a good one.
And man, there's some interesting stuff in here.
Absolutely, yeah.
Real-world techniques, not just theory.
Real world for sure.
So it's laid out kind of like, a real project.
It is, yeah. Like you'd see this at a company.
Oh, interesting.
Yeah, they outline all those steps, from planning the analysis
Right.
to like assessing how well the whole system works.
So, okay, we got develop a data analysis plan,
Mhm.
prepare data, explore data, perform data analysis, and assess the analytics and system. So that's the flow.
That's the process, yeah.
But here's a thing that I found interesting, 2 textbooks.
Yeah,
One's all about IBA, so International Institute of Business Analysis.
right.
The other's like a McGraw-Hill stats book.
Interesting combo.
Different vibes, right?
Totally. It shows you what business data analytics is all about.
Okay,
You need that practical stuff, the standards from IBA,
right.
but also the solid math, the theory behind it.
Mm-hmm.
Like, think of making a cake, right? You can follow a recipe,
Yeah.
but understanding the chemistry, that's next level.
Ooh, I like that analogy.
It takes you further.
Yeah, so it's for really using it, not just the test.
Absolutely.
Speaking of the test, though, there's some jargon in here.
Oh, yeah.
It kind of makes my head spin, I'll be honest.
Like what?
Algorithms and models.
Ah,
Always mix them up.
I get it.
Break it down for me. Like, I'm not a data scientist.
Okay. Think of an algorithm like a recipe,
Okay.
and the model is the dish you make from it,
Oh,
which
right.
you think gives you steps. But the final dish
Yeah.
depends on ingredients, oven, even the cook.
So the algorithm's the process, the model's how it works with real data.
Exactly.
I bet there's tons of algorithms then, like recipes.
Oh, yeah, tons.
Each one for a different problem, huh?
Yeah, just like you wouldn't use a souffle recipe for chili.
Right, right.
Different algorithms for different data, different goals.
The syllabus mentions some specific,
Yeah.
regression, then logistic regression, then decision trees,
Okay,
random forest, then support vector machines,
getting complex.
and then neural nets. Like high school math all over again.
A bit, yeah. Want to run through a couple?
Yeah, quick rundown would be awesome.
Okay, let's start with logistic regression.
Okay.
It's super common in business. It predicts yes-no outcomes.
Like what?
Like, will a customer click an ad?
Oh, interesting.
Or will this loan get approved?
Huh.
It figures out the probability of that thing happening.
So they can improve ad campaigns with that.
They can, yeah.
By knowing who's going to click.
Exactly, yeah.
That's wild.
Data's powerful, right? Then you got neural networks,
Okay.
inspired by our brain.
Whoa.
Syllabus mentions a perceptron.
A what?
It's like a simplified brain cell, the basis of those networks.
Wait, so we're making artificial brains for data now?
Kinda, yeah, in a very simplified way.
What?
Perceptron takes info, processes it, makes a decision, connect lots of them, you got a neural network.
That's crazy.
It's how image recognition works, or those recommendations you get online.
Mind blown. But I'm aiming to be a business analyst, not like full-on data scientist.
Right, right.
Syllabus says it's the data scientist who has the deep technical expertise,
Mm-hmm.
but the business analysis professional provides insights.
Okay, yeah,
So where do I fit into all this?
good question. Business analysts are like the bridge.
The bridge.
Yeah, between data science and the people making decisions.
Oh, okay.
You need some technical knowledge, sure,
Uh-huh.
but your real skill is explaining the findings.
So translating data into, like, executive language.
Exactly. You
Yeah.
help them see the so what of the data.
I like that.
Like a data scientist might find a link between website traffic and sales.
Right.
But you tell the marketing team,
Okay.
hey, boost your social media at these times for more sales.
That's actually useful, yeah.
Actionable insights, that's the key.
The syllabus also really stresses data quality,
Oh, it's huge.
especially in the prepare data and explore data parts.
Makes sense.
Why is that such a big deal?
Bad data, bad decisions, simple as that.
Like what? Give me an example.
Imagine baking with spoiled milk.
Yes.
Cake's not going to be good, right?
No.
Data quality, it's like making sure you got the right ingredients.
So integrity, validity, reliability, and bias. Those are all about that.
They are, yep. Making sure your data is good to go.
Okay, break those down for me.
All right, so integrity first.
Okay,
It means your data is accurate, complete.
right.
No missing info, no errors, stuff like that.
Like a customer order without a customer ID.
Yeah, exactly. Or a negative price that makes no sense.
Right, those are bad.
Could mess up your whole analysis.
Sales figures would be wrong.
Yeah.
Yeah.
Exactly. You wouldn't trust those numbers.
What about validity then?
So validity means the data actually measures what it's supposed to.
Okay.
Like, let's say you're measuring customer satisfaction,
Uh-huh.
but you only look at complaints.
Hmm.
That's not the whole picture, right?
No, mending the happy people.
Exactly. Got to look at reviews, repeat purchases for a valid measure.
So using the right data for the question,
Exactly.
reliability is next, right?
Yep, reliability is all about consistency.
Okay.
Like if you're doing a survey on employee morale,
Yeah.
but you change the questions each time,
Oh, that's bad.
right? You're not measuring the same thing consistently.
Gotcha, got to be standardized.
Exactly, for reliable results. Apples to apples, as they say.
And finally, bias.
Bias. This one's tricky.
I bet. How do we even spot that?
It can sneak in from anywhere, like you're analyzing online reviews,
Okay,
but only from one website.
that's biased.
Could be, yeah. Maybe that site attracts a certain type of customer.
Oh, right, not representative.
Exactly.
Yeah.
You got to diversify your sources to minimize bias.
So it's reflecting the real world, not just a skewed view.
Precisely.
This data quality stuff, it's like detective work.
It is. Got to make sure the evidence is good.
The syllabus also mentions hypothesis testing.
Oh, yeah.
Sounds kind of intimidating.
It's a core concept, for sure.
Even lays out steps for it.
There's a process to it. Yep.
Could you walk me through those? I think that's going to be on the exam.
Absolutely, yeah. Hypothesis testing, it's about testing your assumptions
Okay.
using data, like being a data detective,
Oh,
basically.
I like that.
So first you got to set up your null hypothesis.
So what now?
Null hypothesis. That's what you're trying to disprove.
Okay.
Like innocent until proven guilty, but for data.
I can kind of see that.
So say you're testing a new marketing campaign.
Right.
Want to see if it boosts website traffic?
Mm-hmm.
Your null hypothesis is the campaign has no effect.
Like we're assuming it doesn't work.
Exactly. Then you got to choose your significance level.
Oh, more jargon.
It's just how much evidence you need to reject that null hypothesis.
Okay.
Like how much proof to say, nope, campaign does work.
Gotcha. So like setting the bar for how strong the evidence needs to be.
Precisely. Usually it's 0.05, meaning there's a 5% chance
5% chance of what?
of being wrong, basically. Rejecting the null when it's actually true.
Oh, okay. So we got to be pretty sure.
Yeah, got to have strong evidence.
What's next in this process?
Then you calculate the test statistic.
Test statistic. Sounds complicated.
It just measures how different your data is
Different from what?
from what you'd expect if the null hypothesis was true.
So like if the campaign really had no effect.
Exactly. Big difference means your data saying, hold on, something's up here.
Interesting. Then what?
Then you compare that test statistic to a critical value.
Okay, another new term.
It's just a threshold based on your significance level.
So like a cutoff point.
Yeah, if your test statistic is higher,
Higher than the critical value.
then you can reject the null hypothesis.
We got enough evidence, basically.
Exactly. The data's saying that assumption was wrong.
So we say the campaign works or we don't know for sure.
Yep, either reject the null or fail to reject it.
And then we draw conclusions from that.
Exactly. Answer your original question based on the evidence.
Hypothesis testing is a lot.
It is, but it's crucial for data analysis.
Okay, we'll keep practicing that one.
Good plan.
But before we move on, I want to go back to that so what thing.
Oh, yeah, of course.
It's easy to get lost in all these details.
I know, right? Algorithms, models, tests.
But why are we even doing this?
It's not just about the numbers. It's about what they mean.
Right, the insights.
Yeah, the actions you can take because of those insights.
So whether it's logistic regression or a t-test, the goal is to understand customers, predict markets, make better decisions.
Absolutely. Data is a tool to make things happen.
And that's what makes this so exciting.
It is. It's not just theory. It's real impact.
Okay, the syllabus also goes into descriptive statistics.
Ah, yes, the basics.
Good foundation, I guess?
Yeah, like getting a snapshot of your data.
A snapshot.
Yeah, seeing its main features.
Like before we do any fancy analysis.
Exactly. It tells you about central tendency, spread, shape of the data.
Central tendency. Okay, what's that?
It tells you where the middle of your data is.
The middle.
Yeah, like the average or mean.
Oh, okay.
But there's also the median and the mode.
Wait, 3 different middles. Why?
They're useful in different situations.
Like how?
The mean's great if your data is normally distributed.
Normally distributed.
Like a bell curve, you know?
Okay.
But if you have outliers, extreme values,
that messes it up.
yeah, it can skew the mean.
Oh, so one really high number throws the average off?
Exactly. That's where the median comes in.
The median's not affected by those outliers.
Nope, it's just the middle value when you order them.
So it's more stable.
Much more stable when your data's skewed.
Give me an example.
Like housing prices. One mansion can inflate the average,
Right.
but the median price is more realistic, what most people pay.
Makes sense. What about the mode then?
Mode's useful when you want the most frequent value.
Oh, okay.
Like analyzing customer purchases,
Hmm.
mode tells you the most popular product.
Gotcha. So we got the middle sorted out.
We do, yeah. But we also need to know about the spread.
The spread.
Yeah, also called variability.
What's that tell us?
How much the values are spread out around that middle point.
So are they clustered together or all over the place?
Exactly. There's a few ways to measure it.
Like what?
Standard deviation, variance, and range.
Okay, I vaguely remember those.
Standard deviation's the most common.
What's that do?
It tells you, on average, how far each value is from the mean.
So if the standard deviation is high,
It means the data is more spread out.
like incomes of a diverse group of friends,
Exactly. Very different income.
and low standard deviation means they're clustered close.
Yeah, like weights of apples in a bag.
They're all pretty similar.
Right. Variance is related to standard deviation, actually.
How so?
It's just the square of the standard deviation.
Okay, but why do we need both?
They're used in different ways.
Like,
Standard deviation is easier to understand. It's in the same units as your data.
oh, okay.
Variance is more for calculations, behind the scenes.
Gotcha. What about range then?
Range is the simplest. It's just the difference between the highest and lowest values.
Okay, easy enough.
Gives you a quick idea of how much the data varies.
But not the whole picture.
Not really, no. Doesn't tell you how those values are distributed.
Give me an example.
Like temperatures in a city over a year.
Okay.
Range tells you the hottest and coldest,
Right.
but not how many days were hot versus cold.
Gotcha. So it's good for a quick glance.
Yeah, but use standard deviation for a more detailed understanding.
So we got the middle and then the spread.
Mm-hmm.
What else do we need to know about our data?
The shake of the distribution.
The shape.
Yeah, how the data is distributed across its range.
So, like, is it symmetrical or lopsided?
Exactly. Two main measures for that. Skewness and kurtosis.
Okay, tell me about those.
Skewness measures symmetry. Perfectly symmetrical is zero skewness.
Okay.
Positive skewness means it tails off to the right.
And negative skewness to the left.
Yep, like exam scores if it's skewed right.
Meaning?
More students scored lower, few high scores pulling the tail.
Oh, I get it. And kurtosis.
Kurtosis measures how peaked it is.
Peaked.
Yeah, high kurtosis means data is concentrated around the mean, like a sharp mountain.
And low kurtosis is more spread out?
Yeah, like a flatter hill. Important for choosing the right analysis later.
So by understanding all this, the middle, the spread, the shape,
Mhm.
we get a good picture of our data.
We do, yeah. Foundation for all the cool analysis we can do.
All right, let's move on to something else then.
What's next?
Data visualization. I'm a visual learner, so I'm excited for this.
Good one. It's super important.
Okay, tell me why.
Visualization brings your data to life.
Brings it to life.
Yeah, it helps you see patterns, trends.
Instead of just staring at numbers.
Exactly. And it's great for communicating your findings.
So it's like making the data understandable, even for people who aren't like data experts.
Precisely.
So we have technical visualizations and business visualizations.
Not bad. The syllabus mentions those, huh?
It does, yeah. What's the difference?
Technical ones are for data scientists, mostly.
Okay.
They use them to explore the data, find relationships.
So like they're tools for doing the analysis.
Exactly. Scatter plots, histograms, that kind of thing.
Okay.
Business visualizations are more for communicating insights.
To like scapeholders.
Yep, people making decisions. Gotta be clear and concise.
So dashboards, reports, presentations, that kind of stuff.
Those are the ones, they show the key takeaways.
And what actions to take because of those takeaways.
Exactly. Like imagine a marketing manager looking at ad campaigns.
Okay.
A simple bar chart can show which one's performing best.
Oh, easy to understand.
And then they know where to invest more.
Data-driven decisions, right there.
That's the goal.
Choosing the right visualization seems important then.
Oh yeah, gotta pick the right tool for the job.
Are there like rules for that?
Depends on your data and what you're trying to show.
Give me some examples.
If you want to show trends over time,
Okay.
line graph is your best friend.
Oh, so like website traffic over the last year.
Exactly. You can see the ups and downs easily.
What if I'm comparing different categories?
Bar chart's good for that.
Like sales of different products.
Yep. Quick visual comparison.
Easy to see which one's selling best.
Right. For relationships between variables, scatter plot's your go-to.
Scatter plot. Remind me what that looks like.
Bunch of dots, each one represents a data point.
Okay.
See if they cluster together, form a line.
So like if I'm looking at advertising spend and sales, and the dots form an upward line.
That suggests a positive correlation.
More spending, more sales.
Exactly. The key is keeping it simple.
Simple.
Yeah. Clear, focused on the message.
No clutter.
Exactly. Let the data speak for itself.
So data visualization, it's like part art, part science.
It is. You got to be creative, but also analytical.
Interesting. I think we need to dive deeper into this another time.
We could spend a whole session on that.
Yeah, there's a lot to unpack there.
For sure.
Let's pause here and come back to it.
Sounds good to me.
Data visualization is a powerful tool.
It really is. And we've only just begun.
Okay, so we're back and ready to explore more of this data visualization world.
It's a fun one.
Yeah, I'm really starting to see how visuals can like unlock the stories in the data.
They really can, yeah. It's like giving your data a voice.
Ooh, I like that.
Instead of just numbers, you get a clear message.
So the syllabus talks about different types of visualizations, technical ones and business ones.
Right, right. Important distinction.
What's the difference?
Technical visualizations, those are more for the data scientists themselves.
Okay.
Like when they're exploring the data, digging deep.
So they're like the tools for doing the analysis.
Exactly. Things like scatter plots, histograms.
Yeah, those are more detailed, right?
They are, yep. Focus on those nitty-gritty relationships.
Okay, and then business visualizations are more about
Communication.
communication, right?
Yeah, explaining the insights to people who maybe aren't data experts.
So like stakeholders, executives, that kind of crowd.
Exactly. Got to make it clear, concise, easy to understand.
I can see that. So things like dashboards, reports.
Those are the ones. And presentations, too.
They tell the story of the data, basically.
They do, and highlight the key takeaways.
And what to do about those takeaways.
Precisely. Actionable insights.
I'm starting to get it. Give me an example.
Okay, so say you're a marketing manager, right?
All right.
You want to know how your ad campaigns are doing.
Mm-hmm.
A business visualization, even a simple bar chart,
Yeah.
could show you which campaigns got the best click-through rate.
Oh, so you can see right away which one's working.
Exactly. And then you know where to put your money next time.
Data-driven decisions. This is awesome.
It is. It takes the guesswork out of it.
Choosing the right visualization seems super important then?
It is. Yeah. Like I say, right tool for the job.
Are there any, like, rules of thumb for that? How do I know what to pick?
Well, it depends on your data, of course,
Okay.
and the message you're trying to get across.
So different visualizations for different goals.
Exactly. Like if you want to show trends over time,
Yeah.
line graph is your friend.
Oh, like we talked about before, website traffic over a year.
Precisely. Easy to follow the changes.
What if I'm comparing categories, though?
Bar chart's great for that.
Like sales by region or something?
Yep, you can quickly see which region's doing best.
Or worst, I guess.
Or worst. Yeah, that's important too.
And then, what was it, scatter plots?
Yes. Those are for relationships between variables.
Remind me how those work again?
So you plot your data points, right?
Data points. Okay.
And each dot represents one piece of data.
Okay.
And you see how they cluster, if they form any patterns.
So if I'm looking at, like, advertising spend and sales again.
Mm-hmm. And they form a nice upward line.
Meaning?
Strong positive correlation. More spending, more sales.
Ah, starting to remember this stuff.
It'll come back to you.
But the key is keeping the visualizations simple, right?
That's a big one, yeah. Clear, focused, no clutter.
Let the data do the talking.
Exactly. A cluttered chart just confuses people.
Makes sense. So data visualization, it's kind of an art then.
It is. There's definitely a creative side to it.
But also technical, right?
Oh, absolutely. You got to understand the data, the tools, the technique.
And the audience, right?
Oh, yeah. Big one. Who are you presenting to?
This is a lot to consider.
It is, but that's what makes it so interesting.
All right, let's move on to something else now.
What's up next?
The syllabus mentions inferential statistics.
Ah, yes. We're getting into the good stuff now.
Okay, but before we dive into that,
Sure.
remind me, what is inferential statistics again?
It's about going beyond just describing the data you have.
Okay.
It's about using that data to make predictions.
Predictions.
Yeah, about a larger population based on your sample.
So like tasting a spoonful of soup
I like that.
and knowing what the whole pot tastes like.
Exactly. That's a great analogy.
So how do we do that, go from sample to population? I mean,
That's where things like hypothesis testing come in.
right, we talked about that before.
And confidence intervals, regression analysis.
Okay, lots of tools for this.
We got a whole toolbox for inferential statistics.
Let's break some of those down then. Hypothesis testing first.
All right, so remember, it's all about testing assumptions.
Assumptions about the whole population.
Right, exactly. Based on the data from your sample,
You set up your null hypothesis.
which is what you're trying to disprove.
Right, like innocent until proven guilty for data.
I love that analogy. It's so true.
And then the alternative hypothesis is what you're actually trying to show.
Yep, that's the one you're hoping the data supports.
Give me an example, something concrete.
Okay, imagine a political poll, right?
All right, I'm following.
They survey like 1,000 people.
That's the sample.
Exactly, to estimate how the whole country might vote.
So the null hypothesis would be
That there's no difference in support between two candidates.
across the whole population, you mean?
Yep. And the alternative hypothesis is that there is a difference.
Okay, so then they crunch the numbers, do their calculations.
Right, they get their test statistic compared to the critical value,
And if the test statistic is high enough,
meaning the difference in their sample is big enough.
they reject the null hypothesis.
Exactly. They say, okay, our data suggests there's a real difference in support.
Even though they only talk to 1,000 people?
That's the power of influential statistics.
Pretty cool. What about those confidence intervals, though?
Those are a way to estimate a population parameter.
Parameter, like what kind of parameter?
Any kind, really. Average height, proportion of people who like a product, anything.
Okay, so it gives you a number, like the average height is 5'8".
Not exactly. It gives you a range.
A range.
Yeah. And you're confident that the true value falls somewhere within that range.
So like we're 95% sure the average height is between 5'7" and 5'9".
Exactly. The wider the range, the less certain you are.
And the narrower, the more precise.
You got it. Important for decision making.
How so?
Well, let's say you're launching a new product, right?
Mm-hmm.
You do a survey to see what people think.
Okay.
A confidence interval tells you how much you can trust those results.
So if the interval's really wide,
Your sample might not be very representative.
you wouldn't want to base big decisions on that then.
Probably not, no. better get more data.
Makes sense. Okay, what about regression analysis? We kind of skimmed over that.
Ah, yes, regression. That's a powerful one.
The syllabus made it sound like you can predict the future with that.
In a way, yeah. You can model relationships between variables
Okay.
and then use that model to make predictions about what'll happen.
Give me a business example. I'm having trouble picturing this.
Okay, imagine you're a retail company. You want to predict sales for the next holiday season?
Yeah, that'd be useful.
You can use regression analysis for that.
Really?
Yep, you build a model that includes things like historical sales data,
Okay.
economic indicators, marketing spend, even weather forecasts.
And that'll tell me how much I'm going to sell.
It can give you a pretty good estimate, yeah.
That's crazy. But how do we know what factors matter most?
That's the beauty of regression. It tells you that too.
It does.
Yeah, you can see which variables have the biggest impact on the prediction.
So, like, maybe marketing matters way more than the weather.
Exactly. And that helps you make strategic decisions.
Do we boost marketing or focus on something else?
Exactly. Regression gives you that insight.
This is incredible stuff.
It is. Inferential statistics is all about unlocking those insights.
And making better decisions because of them.
Precisely. It's about using data to understand the world around us.
This deep dive has been mind-blowing.
Glad you're enjoying it.
I'm definitely going to need some time to process all this.
It's a lot to take in, for sure.
Let's pause here and come back for the final part.
Sounds like a plan. There's still more to explore.
I can't wait. All right, so inferential statistics, right? Still wrapping my head around that.
It's a big one, for sure.
Yeah, using data to predict stuff about, like, whole populations.
Pretty powerful stuff.
But the statistical test, I'm still a bit fuzzy on that.
Ah, yeah, the Z-test, T-test, all that.
Yeah, when do we use which one? Always get them mixed up.
It's about picking the right tool like we were talking about with visualizations.
Okay, so the Z-test and the T-test, those are both for comparing means, right?
They are, but the Z-test, you need to know the population standard deviation.
And we usually don't know that, do we?
Not in real life, no. So T-test is more common.
Makes sense. So if I'm comparing, like, salaries of men and women in a company, I'd use a T-test because I don't know the standard deviation for, like, everyone.
Exactly. The T-test is your go-to for comparing averages in most cases.
Okay, what about the S-test then?
That one's for comparing variances.
Variances, right? How spread out the data is?
Exactly. Like, think of stock prices.
Okay.
Two companies, you want to see which one's stock is more volatile.
Oh, so which one's more of a roller coaster up and down?
Exactly. Higher variance, more risky, potentially.
And the F-test tells us that.
It can, yeah. It compares those spreads.
Okay, and then the last one was the chi-square test, right?
Ah, yes. Chi-square is for categorical data.
Categorical meaning, like, not numbers.
Well, not continuous numbers, more like categories, groups,
Give me an example.
like transportation methods, car, bus, train, bike.
Okay, I see.
You want to see if there's a relationship with, say, gender.
Oh, so, like, are women more likely to take the bus than men?
Exactly. Chi-square can help you answer that.
So many tests. I'm starting to see how they each have their own purpose.
It's like having a whole toolkit, right? Got to pick the right tool for the job.
Okay, let's talk more about regression analysis, though. That one really intrigues me.
Yeah, regression's cool. It's all about prediction.
Like we were saying before, right? Predicting sales and stuff.
Exactly, but it can be used for all sorts of things.
Give me another example, something different.
Okay, let's say you're a bank.
Right.
You want to predict whether someone's going to default on a loan.
Ooh, that's a big one for sure.
You can use regression to build a model.
What kind of model?
One that takes into account things like their credit score,
Okay, that makes sense.
their income, their debt, maybe even their employment history.
And that gives you a prediction, like, yes, they'll default, or no, they're good.
It gives you a probability, yeah, how likely they are to default.
So you can make decisions based on that.
Exactly. Who to approve for a loan, what interest rate to offer.
Data's really powerful stuff.
It is when you know how to use it.
This deep dive has been amazing. I feel like I've learned so much.
Glad to hear it. It was a lot to take in, but it's all connected.
Yeah, from those basic data types to these fancy statistical tests.
It all builds on itself, and it all leads to better decisions.
That's what I'm taking away from this.
That's the key, using data to make things happen.
All right, so to our listener, if you're prepping for that business data analytics exam,
Good luck.
remember, this is just the start. Keep learning, keep exploring,
Don't be afraid to get your hands dirty with some real data.
and don't forget those visualizations. They can really bring those insights to life.
Absolutely. A good chart is worth 1,000 words.
Well said. Thanks for joining us on this deep dive.
My pleasure.
We'll see you next time for another data adventure.